For our combined events of coffee and tea drinking, we can show these on a tree diagram. So the first branches of the tree just looks at the first event or one event, and we're going to choose coffee. And 4 out of 10 of us prefer drinking coffee or like to drink coffee. So we're just going to write that in the coffee split here, 0.4. And the remainder of us, 6 out of 10, do not drink coffee. So that's 0.6 out of everybody. Next branch or split of the tree, we're focusing here on just the coffee drinkers, and we split it out into the second event, drinking tea or not drinking tea. So from our table, of the coffee drinkers, 1 in 4 drinks tea. So we write that there as 1 divided by 4, or 25%, 0.25. And the remaining 3 in 4, 75%, don't drink tea. So the second branch here just looks at the coffee drinking split, and so we're just honing in on these 4 people here. But do notice that the split out here, the 2 branches that come out here, add up to 1 or 100% because it's of these 4 coffee drinkers, of 4 of them. And this branch here also adds to 100%, as will this one here. So we find this last one here by looking at the tea drinking behaviour split out according to the non-coffee drinking group, and we notice that 2 out of 6 enjoy drinking tea, which is 0.33, and the other 4 out of the 6 don't drink tea, so that's 4/6, 0.67. When we look at combining the 2 events together, the 40% of the coffee drinkers, a quarter of them drink tea. So this first out of our 4 possibilities is 0.4 times 0.25. In other words, a quarter of the 4 people, 0.25 out of 0.4, which is 0.1, are coffee and tea drinkers. For our second branch, which is coffee and not tea, again we multiply those 2 numbers. So we're multiplying 0.4 by 3/4, and that's 0.3, 3 out of 10 people. Our 0.6 by 0.33, is roughly 0.2 rounded, and our 6 people, 3/4 of those, 67 of 0.6, do not drink tea. So we multiply those 2 branches together, and that's about 0.4. So what do we notice here? Well, 0.1 plus 0.3 plus 0.2 plus 0.4 always adds up to 1. So when we add down the branches, or when we add these 4 values together, 4 combined events, we get everybody back together. And you'll also notice here that the coffee and tea drinkers, this 0.1, is this one person here. Okay, so we've effectively split this out down into our 4 cells, this tree. And we also notice that the 0.3 are coffee and not tea drinkers, and that's our 3 people here. And our 0.2 here is not coffee but drinks tea, so that's our 2 people here. And our last one, our 0.4, is not coffee and not tea, which is this 0.4 here, or 4 out of 10. So the ends of our branches is actually the guts in this table here. But we start off by looking at the subtotals here of the coffee drinking behaviour, and then splitting up the coffee drinkers according to, and non-coffee drinkers according to whether they like tea or not. And so we end up with these here, which is quite handy. Now, coffee was the hero. It started out first, and then we split it into tea. We could have done it the other way around, but not to worry. If you're going to be answering more complicated problems and you need to know what the tea drinking portion is, because you won't have all this information in a table, you can actually pick it out. Now let's check out what that is. The tea drinkers in our table here is this row here. So these are the ones that drink tea. So a total of 3 out of all of us in the class, out of 10, are tea drinkers. So the probability of drinking tea from this group here is 3 out of 10, 0.3. You will notice from our tree diagram that regardless of whether they liked coffee or did not like coffee, we have 0.1, or one person here who likes tea, and we have this 0.2 here that also likes tea. So from this tea diagram we can actually add up this figure, this 0.1 plus this 0.2, to come back to our probability of drinking tea, to come back to this figure here. And that's all we do. We just simply add these up. And what this diagram shows us, this tree diagram, is irrespective of whether they drink coffee, we have 1% of everybody here, plus out of the non-coffee, from the non-coffee drinkers, this 0.2 out of the total is the other portion of our tea drinkers here, and we add them up to make the 0.3. We can also answer other questions about the combined events, about the two behaviours, by using our tree diagram. So we can look at other combinations of events. They might ask us what's the probability that someone does not like coffee or tea, and so we can rock down this final branch and go, oh well, we know 0.4 don't, and similarly they might say what's the probability that people like coffee or tea or both, and we can add up the 0.1, 0.3, 0.2, in other words the 0.6, which was our union, but pick this out from our tree as well. So our tree is a different representation of the table. It's good to practice dealing with trees and understanding them, but I'm finding that in the new curriculum and in the exams, if these confuse you, the tables are much clearer and can be used in the place of trees, provided you've got enough information. And if you don't, you might be able to partially fill out a tree and have enough in there to answer the questions anyway. So the contingency table, as we call it here, the two-way table, is extremely powerful, but the tree diagram will give you similar information accordingly, or split out accordingly, and it does contain the separate cells at the end here.